Thank you very much, Judy, for joining us today. So this is the second session as part of the SydCHI talk series. And today we have the pleasure to have Professor Judy Kay with us to talk about, in a world awash with personal data, how can we empower people to harness and control their data. Professor Judy Kay is Penn-Scott Distinguished Professor of Computer Science. She leads the Human-Centered Technology Research Cluster at the University of Sydney. And the main focus of her research is to create infrastructures and interfaces for personalization, especially to support people in lifelong, life-wide learning. Her research has been commercialized and deployed, and she has extensive publications in leading venues for research in user modeling, artificial intelligence in education, human-computer interaction, and ubiquitous computing. She has had leadership roles in top conferences in these areas and is editor-in-chief of International Journal of Artificial Intelligence in Education, as well as editor of Interactive Mobile Wearable and Ubiquitous Technology. Thank you very much, Judy, for accepting our invitation. Over to you.
Okay, thank you very much. I think I'm going to tailor this a bit to the people who are here, but oh, I see there are some people with cameras off as well. Okay, so I'll screen share now. Hopefully the correct one, yes. And now all the people, I'll just move you around because I like to look at you at the same time. Whoops. Okay, so back to the title. And I'm really pleased to talk about this because it's both taking things I've done before, and many of you will know about some of them, but also about how I want to take that into the future. And hopefully people here will want to come and talk about ways we could collaborate and ways you could give advice on how we can do things better. I can do things better. Thank you for the introduction, so I won't say who I am. There are 5 parts to this, so you can track the progress. The first, I'm going to briefly talk about the driving goals for my work, or one way of viewing them. Secondly, an overview of what I see as a really big vision that started with my PhD work just over 20 years ago, and it's in this area of building whole systems so that people can harness and control their personal data. I'm going to introduce this word scrutability. I think most of you here have heard it, but maybe you haven't. Then the case studies as promised in the abstract, both from long-term data and from areas where they're called open learner models. And then a research agenda and hopefully some discussion. Okay, so so what are the driving goals of my work? And I've been struggling with how to describe them well. And so I've got this balance, and we academics obviously start with things we know how to do, technology and their methods, and especially engineers tend to take their little technology and focus on it. But I also like to think that I'm really battling, really doing even more to start with problems I want to tackle and that will inspire me to learn new methods if I have to, find collaborators. And these on the right are the ones that are my passion. Firstly, lifelong, life-wide learning. And below that, and often linked to it, health and wellness. And then in addition to that, this control of personal data and its use, which is something people say they want to do and want to be able to do, and it's been getting more press of late. And then on the left, I've got the things that are their servants, the things I want to do to the tools I want to use, ubiquitous technologies, immersive technologies, including augmented reality, whatever we want to bring to bear, and HCI, and moving into information visualization. So the reason I present it this way is that I believe that much of engineering rightly has people who've learned to make hammers and go looking for nails. And I feel always inspired to start with the problem and then work out what hammers we need, which is why I'm pleased to be talking to you. Maybe you can come and bring the right hammers to tackle things. So firstly, some background, and fairly quickly through this whole notion of scrutability. And okay, so a whole lot of people here who've contributed And it's been over many years where we built infrastructures, especially Bob, who's here, and a number of PhD students. Multiple meanings of user models. I want to start with this. And there are three common ones and two widely used in computer science. And I'm going to group them. I've actually got four here, I realise. Firstly, we talk about a user model as my model when I'm a designer of the user. So it's something in a person's head. The second one is the implicit model that I build into software that I design because I had the user model in my head. So those are very pure HCI ones that turn up in older HCI textbooks. In the work I do, it's usually a machine representation of this user, a set of beliefs the machine has about a single person. And in the AI world, more and more, the same term, user model, is used to refer to some data structure thing or algorithm, in fact, that is based on a lot of data from a lot of people and enables you to do the sort of stuff AI people are increasingly doing with people's data. And unfortunately, we often get confused because we're talking about different things. I'm mainly talking about the third one. So what does Scrutable mean? And here's a dictionary definition, and it's got some synonyms for it. And above all, it's if something's scrutable, a person can understand it if they examine it very carefully to discover information. That's the stuff I'm really interested in. It's relevant for learning, but it's relevant for people understanding their own data. And I want to give an example of something that's inscrutable. And this was once in Google Mail where it said, hey, I think this is important because of our magic sauce. Nah, I'm not going to tell you how it works. And Google has actually changed to give more meaningful information, but it's not easy. Now, I just want to emphasize that we often talk about AI, whatever that means, and we sort of blur the line between people. There's human teaming is a big area, and you often talk about equal partnerships. I see them as very different, but people are fundamentally inscrutable. We can't know what's in another person's mind. I am really pleased to have all your faces in front of me because it gives me a chance to guess, and that's why I've taken pains to reorganize my fields, my screen, so I can see your faces. But we really don't know what's going on. Self-knowledge is pretty hard too, and my favourite metaphor at the moment is this Jonathan Haidt elephant and the rider, where the elephant is what's really driving what we do and the rider is our conscious mind thinking or wishing they were controlling us. And that's a real challenge for building interfaces and helping people learn and just about everything else. But machines shouldn't be inscrutable. I'm sorry for the double negative. They should be scrutable. And when we build them, we should bear that in mind, but we don't. And we should aspire to make them deterministic. Hey, you know, I've written a lot of code. That's great aspiration. And put a priority on design for scrutability. And I think that we hear so much now. And in fact, I was asked to give 2 keynotes this year on this broad topic, and it made me think very carefully about it. So I want to share some of that. So firstly, if we build systems, we should enable people to answer these questions. They're sort of what HCI would call benchmark questions. What does this system model about me? What data, what user model is it building? Do we bother to even try and do that? What data does it use? That's easier, right? It ought to be very easy for me to find out what data something is collecting. Where does the data come from? Is it raw data from somewhere, or did the system infer it, or whatever? How is it used, perhaps outside the system? How does the data get interpreted? And maybe even can I control that? And where does my data go? So there's a bunch of papers, but Bob and I wrote one recently as the BJET 50th anniversary issue, and exploring this for the context of learning. But fundamentally, it's a foundation for people controlling things or just deciding not to use them. So why does it matter? And I have this picture that actually came from my thesis. So, you know, here is something in a person's mind when they're trying to learn. And over on the right, we have the machine's model of them, the user model. And so, on the left, there's reality. On the right, there is the machine representation. And there's obviously a hard line between them. And now I'm going to put a dotted line with the aspects between the dotted line and the solid line are things that I have shared with the computer. For example, I've used the computer and provided information. And there's a corresponding thing on the machine side with information it's shared with me. And I think that that is a really nice way to think about how you can analyze what's going on and start making sure the machine can share what it uses to reason about the person. Special things about scrutability. Well, firstly, I believe that when you're a learner or when we have contexts where tertiary educators and we want our students to learn, they should be responsible for their learning and feel in control of their learning. They are in control. They can decide to do lots of things to subvert us. But the machine should be thought of as definitely the servant or aid to the learner and reflect the asymmetric relationship between them. We should make sure learners can see their personal information. I've been this semester trying to do some stuff with learning data, and boy, was Canvas not designed to do this. Notion of programmer accountability, that's true of all of the work we do. I should be able to judge the correctness, acceptability, and fairness of whatever the machine's doing. That might help me trust it. It might mean I share it, which could be good for learning. Above all, the data we have about people for any aspect of learning is usually very limited. I'm going to go through some examples in a bit of that and my work. And we need to really build things in very clearly encapsulating our understanding of how imperfect our data is and how we dealt with it. And then we have this notion of metacognitive processes. And I was going to put some pictures of people reflecting, but one of the things our data should do for us is enable us to get a better understanding of ourselves and do these core metacognitive things of reflecting on how we're going, planning what we're going to do next, and monitoring our progress and being able to judge whether we've learnt things or not. So there they are, the list. And this is all a foundation for control, which I think is important. I want to highlight why I chose this word scrutable, and it's because there's a lot of work being done on transparent, fair, accountable. It's called FATE or FACT or whatever. There's a huge amount of work and very multidisciplinary, but none of it seems to recognise the complexity of building computer systems and the amount of user effort involved. So what I look at is we hear the word transparency, which is in the bottom middle, which is all about, implies that you make no effort at all and you can understand it. Whereas high effort is something like controllable or debuggable, and Scrutable's right up there. And then on the right, we've got a notion of machine-centered, which is explainable AI. The machine explained it. Your job to work out what it means. And I see the other terms on the left as being a bit more user-centered. And so Scrutable, in my view, is both of these. And I think part of my research agenda is to build systems so that they are more scrutable. So how can it work? And there's a bunch of papers here. The more recent one that I already mentioned and earlier ones. Okay, so just to very quickly go through, we've got raw data. I'm coming back to that in a bit. Data after we've cleaned it. I'm going to come back to that in a bit. There's all sorts of stuff we might do with it. And I'm actually seeing that is where the AI community is putting all its energy. And I actually think that we need to do much more with the top two layers. But eventually we could build a long-term user model, which is data that some system keeps about me. And then there are issues of how it's interpreted and how we can build personalization. And I would like to build a scrutiny and control layer on systems. And I don't see most of the world that builds the Facebooks, etc., hasn't even tried to start with the foundations doing that. And so, explaining the raw data ought to be fairly simple. But the long-term user model is the stuff that's sitting in the machine and should be valuable. I emphasize that often it has multiple interpretations. And given the data is very poor quality, when a user interacts with it, there's a chance for them to actually provide the knowledge they've got that the system doesn't, because the information wasn't shared. And finally, lots of things are personalized. That's the hardest bit, but we'll have to get a lot more work to be able to support that. I'm very quickly going to show you a bunch of the things that might have to happen, and I'm not going to talk about any of them, but each of them is different bits of the problem, and lots to scrutinize, because for this talk, for an HCI audience, the real issue is the HCI challenges are huge. So where do we go? And now to the case studies. And I want to start with one related to wearables. Everyone's wearing these smart watches and so on. And Li-Ming Tang and I sat down several years ago and said, hey, this data ought to be useful in the long run for people to understand themselves better. And so he had a couple of papers that I'm going to talk about. And I'm going to show you the interface he built. And it's got text, but I'll take you through it. And the idea was we wanted people to look at data that was from several years. And this was actually data from the tutorial, so a fake user. And so this user has got a target of 10,000 steps a day. And sounds simple. And you can see they're mousing over. They actually did 14,000 that day back there. They've got light blue set up to be 50% of that goal. And you could see that was editable, so you could change it if you wanted to. And then white means you didn't even make 50%. So there are some days. And if you look carefully, the weekends, the top, the Saturday and Sunday are always white for this fake user. And grey is when the user had no data. So they weren't wearing the tracker, which amazingly, this gap has had very little attention. So you can change your target, which of course the literature says if your goal was 10,000 but you never make it, you might do better if you set a more modest one. You can also change the level at which it goes light blue. And this enables you to tinker with looking at how close you went. But then I want to get on to this hours of wear. And we discussed the fact that, see down there, the person averaged 13 hours a day. So the data is pretty reliable. And in fact, none of our users gave a damn about that, I'm afraid. But I'll come back to that. And in fact, I won't. I'll skip on from the rest of the video. I will stop the video and go on to the next slide. I'll try and go to the next slide. Why is it not going to the next slide? Okay. So this was the interface you saw, and you could mouse over it. So that was pretty important. And Li-Ming did some lovely studies, and people could discover all sorts of things. In fact, people would look and say, hey, oh, I was very active then. And one of my most exciting ones was a person who said, oh, they had several years of data. And they said, look, when I moved to the suburbs, I suddenly became less active. So that was pretty exciting. Li-Ming then built this interface at the side that was a little bit of scaffolding, which I think we have very little scaffolding in the world. And I think this is a direction that is really important. And so he had this thing that said, well, you know, your goal's 10,000 steps. Ask yourself, am I on track? You know, should I change my goal? Because I'm never making 10,000. And what about weekends? And interestingly, in Li-Ming's study, most people at the preliminary interview couldn't even make a guess whether they were more or less active on weekends. Our public health researchers tell us most people are less active on weekends, interestingly. And people needed the prompt of this little bit of very simple scaffolding to help them. But the users got always a constant one, and they said they wanted a personalized one. So the next step was that wearables like this can give us lots of data, and I'm going to focus on steps, but my smartwatch does a whole lot of things. It can do heart rate variability, which is an indicator of stress, could be very interesting in the long run, especially correlated with something else. It does heart rate, which could give very rich insights about a lot of things. So there are lots of things already and more coming. In fact, I had a meeting recently with someone who's using just this sort of technology to give you a heart age, which obviously changes only slowly. So long-term data has an incredible potential power for people. So what was our insight from this? Well, firstly, this is really deep. You'll all be stunned. If you're not wearing the watch, it doesn't collect any data about your steps. Hardly surprising. And yet, most of the places, most of the interfaces ignore that. If you wear your watch 3 days of the week, typically, if it tells you an average on a long-term interface, it will just average over 7, divide by 7. But we really wanted to look at how to take account of this incompleteness, because we know it's going to be incomplete. And so our driving question, suppose the user wants to know, well, how many steps do I walk each day, like in the interface before? And we know that if the person had perfect adherence to the way the device works well, in other words, they wore it 24 hours a day, it would be complete. But I mean, they've got to take it off to get it charged, and you forget to wear it. And there are a lot of reasons why the data is incomplete. So we said, well, what is the impact of that? And we did it with Fitbits with 12 data sets. And the spoiler is here that we found that there were clinically significant differences depending how you interpreted the data, which is pretty important. So this is showing you the 12 different data sets, and I don't have time to go through them, but I just want to focus here on one group where all the ways we interpreted the data were much the same. These were people who volunteered their data, and they wore their Fitbit a hell of a lot. This was a bunch of Sydney Uni students who were the exact opposite. A lot of them didn't wear it very much. And here we had a couple of thousand. You can see it's down at about 6,500 steps if you use one interpretation of the data, and it's closer to 9,000 if you use another. And that's a clinically significant difference, and we should be using it. So what was cool was, and I'm still working on interfaces to show that what our uncertainty is and how we make that clear to people and let them understand their data. So we've got a number of ongoing student projects. But we actually, in this collaboration with Brian Lim, it turned out that that insight about taking it into account whether people were wearing the device or not proved really useful for analysing data from 140,000 people. So here is one person, and all the blue bars are how far they walked, and you can see sometimes they even did 20,000 steps in this data set. But these things on the left are various measures of how much they didn't wear it. And when you think, I mean, to be honest, when we were initially doing work, I didn't actually think that this streak stuff, which is how long the periods are that you do or don't wear it, I didn't think it would be meaningful. But I realised, especially when it turned out to be very valuable, that it does make sense. A choice for a person to wear the device or not obviously is related to that elephant that's driving why they're doing things and how important it is. So we did some clustering, and we came up with people with things that look like this, you know, slow starter with little bursts, other people who were described as hop on, hop off, intermittent, and other self-driven powered people. And when we use that approach, we were able to build nice predictive models. So here we were, we started with the question, hey, how many steps do I walk each day? And what's the long-term trend? I'd like to understand myself better. We worked out the fact that the data is incomplete, means we need to get better interfaces for individuals and need to understand more about how to use the data. And that turned into a useful way to do machine learning and data modeling. So now, as promised, I want to switch to formal education, and I'm just looking at who's here. And obviously some of you, well, most of you are in the tertiary sector, and all of you have gone through it. So I want to show you some of the open learner models. LMART is a seminal piece of work that's still running. You could go to LMART and learn Lisp on the web today. And it shows you on the left, when you first come in, it says to you, well, this is where you're up to, which is you're ready to do lesson 1, it's green, and red indicates that you're not ready to do any of the others. And as you progress through, it changes and so on. And it's a very nice, firstly, it's a model of your progress, which I would call thinking quickly, seeing quickly that you're making progress, but it also gives you guidance on navigation through the learning materials. Very cool. This is a really nice one where you show progress. Tanya Mitrovic did this lovely interface with beautiful evaluations showing that it really helped people learn, especially the students who were at the low end of the class. And basically they were using this tutor to learn SQL, and then for this bit, the green bits are the stuff they'd covered and done correctly. The red was what they had done wrongly, and the white was still to come. And the students really used this to guide their practice. Susan Ball did a beautiful review paper. If you're interested, I highly recommend you look at it. But she had looked at a lot of these. One of my favorites is this one on the bottom, which was for kids learning arithmetic. Starting from the left, if you got problems right, the tree grew and grew and grew. And unfortunately, if you got them wrong, it went backwards and further down. Here's another one that Peter Brusilowski's group is still working on. This is a 2018 version, but it shows you for a Java course how you're doing. You can see these variables, primitive data types, etc. The green is you, and the blue is some group you compare yourself with. And when you click on the loops, you can scrutinize more detail and work out where you went wrong. And in systems we've built like this, you then click on a quiz if you did badly and redo it, or click on an example and make it go brighter green. This is another cool one from Vincent Eleven's lab. And the cool thing about this was it's for kids learning arithmetic. You'd see on the right, it's about multiplication, division. Similar idea, the longer the green, the better. And but the thing he did was, if you first of all asked this question, how well do you think you can solve the level 3 problems and so on? In other words, get the student to stop before they saw it and think about their own progress, they learned more. So we've got a whole body of work that's at the moment sitting in the AI Ed literature, but I would like to mainstream it. We also have closing the rings in growing areas, and Stephen Ritter is the industry area, but it's still about learning maths. In our own work, and several of you would know about it, I've got Erin there because Erin got us into this tabletop work some time ago. And the people on the left are all the PhD students who did amazing work to make it fly. And we very bravely or stupidly ran a classroom with 5 tabletops for a whole semester for 2 whole subjects with several tutes, and the students did various activities. But this was using the data for a teacher dashboard to help guide the teacher in how to manage the classroom. So got lots of experience on that, but this has also influenced another thing. So here is a thing that Martin was very much involved in, the side of our building on campus. Here is a large interactive wall, which you could interact with using gestures. And here is a user who is a whiz at it, doing a right arm swipe or an arm up. So how does someone learn how to do that in order to navigate their way through this information space? And I've shown it to you here. It's in a hierarchy. You start at the top level, and you explore bits you're interested in. So how do we help people learn? We had what I believe is an open learner model, though I don't think I ever talked to anyone there in the team about it at the time. But basically, we always had this set of icons on the screen, and as you mastered each one, it changed so you could see your learning progress. And I can see incredible opportunities for this in so many places as part of this scrutability. Okay, so interestingly though, and when we had long sessions, we found people were playing and really playing. And we found that we could compare, on the left, you can see that the person is represented by an outline shape, and on the right, more like a skeleton shape. And that made a difference to their learning, but it also made a big difference to their playfulness. And so I think that two key insights about that I'd like to carry into my further walk is, firstly, the notion of an open learner model, even here when people need to learn. And the second is the idea that play is something that should be more a part of things, not just games, but take account of people being playful. For the very least, it ruins their data, right? When our students, for example, tinker with the system and want to answer questions wrongly, we should set things up so they can, and we don't. Canvas really isn't set up for that. We're looking for a platform that does better. So now to the promised research agenda, hopefully with time to discuss it. I really want to build interfaces to help people see, understand, and make sense of especially their own data. And I had quite a heated discussion. This is my PhD students who are all working on this aspects of it, I believe, or are heading towards it potentially. I had an argument with someone who said, look, you don't need anything to help you learn at an interface. If people want to know things, they just Google them and, Stack Overflow or whatever. So I think that fails to acknowledge this diagram here. So what I've got is that the top is for things that people need to know for some situation. And on the right are things they believe they need to know. So, for example, over here is something I need to know, for example, functionality of Zoom, and I believe I need to know it. So that's the stuff where I will go to Google and ask for help because I know I need to know it. But there's a lot of stuff over here that I need to know, but I don't know about it. And this is, the number of hidden affordances of Zoom and the things that I had no idea you could do and the new features that come in every week. The world is full of this, and we're not building systems to take my personal data, which could indicate whether I've done things or not, and to help me look at the stuff that could be on my learning agenda and could be helpful. And over here, of course, we've got the things I believe I need to know, but I don't. And the solutions for that are a bit different. So we need to build interfaces to address the different needs differently. An open learner model can show you your progress, and it could also show you what you don't know. But scaffolding will be critical, just like in Li Ming's diagram of the physical activity. If you don't look at the weekends, you don't realize weekends are worth thinking about, you won't be able to see that that's a problem. So we need scaffolding, and it should be personalized, which then makes two layers of scrutability because now we've got personalization of the help with understanding our data. So some of the contexts where my students are working that I think all of this is important, I'll go through some of them. Bernard is doing clinical indicators where there's huge amounts of data in hospitals about doctors, and we'd like to make them useful for long-term learning and improving their practice. So it's an area that is tentatively called practice analytics. Samine is working on accessible design, and she has a very cool plug-in for a whole lot of design tools to help designers do a better job of accessibility. And that will be something just like this picture. Some of them know they need to know things, some of them don't, and so on. There is Alan Young is working on a project on informed consent in cancer consultations. And again, a lot of that is about the clinician helping the patient understand the things they need to give truly informed consent. Next one is games for learning. That's Jonathan, who is the next student along. And he is looking at what data you get. If you have a game, obviously there are many games for many things, but many of them are meant to help you learn something. Do they actually have a learner model, and do they make learner models serve that goal? Next one's truth decay, which you can ask me if you don't know what that means, but it's a cool term to describe things to do with fake news and people learning better how to negotiate with, understand the world, see the news, and see when things are trustworthy or not. And finally, Kim, who's starting her PhD, is planning to work on communication in environmental modelling. And again, a real focus on data being uncertain and helping people understand it. So very much a model of what I'm doing in understanding data. Bob and I have another project that's just started, which is in line with the things I showed you before. And I've highlighted that we've got this idea of an e-textbook, and there's a version built already. And the idea is that you have a personal user model for learning with an open learner model attached. But the thing is that data is kept entirely in your own system. So you don't have to log in. No data is kept. The mothership keeps nothing. It's all yours. And it's very much in the spirit of giving people control over their own data and understanding it. So a whole lot of people who've been involved in a lot of this stuff, and that I've just thrown in the infrastructures, UbiComp interfaces, and all this lifelong, life-wide learning. So I'm over to you, and I'm going to share my other elephant, which is we each see different things, and I'm hoping you will help me to put more pieces together and see things and understand them better. Thank you.
Thank you very much, Judy. So time for questions.
Yeah, thank you, Judy. Really nice to see. Oh, sorry, I just started without raising my hand. Sorry, Aaron. Really nice to see all your work in coming together in one really interesting narrative, and all these connections. To the point that you made about Facebook and the raw data and the user models, I think you had a nice diagram there. I guess my question there is, or what I was thinking, while sharing what I was thinking, was that actually Facebook knows a lot about the users, because they create very rich user models to sell, to help target them through advertising campaigns. Right. So I don't know if it's about really them not having the abilities to do that, or it's just they don't have they don't feel like there's an incentive to do it, rather, because you could use all the data to have essentially to let you to allow users to scrutinize the algorithms, which is what you are advocating for. Yeah, so it's a comment and a question in there, I think.
Yeah, so I was I gave a keynote at the multimedia conference, and actually it was very much more about scrutability. And some people who I was told afterwards were from a company like Facebook or Google or whoever said, we don't understand our own algorithms. So how can we explain them to the user? And my whole point was that if you didn't start out building these systems with the goal of explaining something to the user, how should you be surprised that it's hard to do later? And it is true that a lot of the stuff they do is this machine learning that's set off on its own, and that nobody does really understand. Mm. And I guess, I don't know, not me, but legislation may force people to rethink that and change it. Mm. And I'm not sure how smart the Facebook stuff is. It just has to be smart enough to convince the advertisers to part with money and to give them enough money that they think that it's a benefit. So I'm not sure how much, quote, Facebook knows, if that makes sense.
Mm. Yeah, okay, interesting. Yeah. I think it could also be Facade to some extent, because I've used their advertising platform myself for promoting events, for example, when we did the media architecture biennale, and I was surprised how much you can specify who you want to target, because there's much more in there what you can tick than there's actually people report about themselves. Like whether you want to target parents, for example. So at least they pretend that they have all these models, but you're right. Interesting to hear that they say themselves they don't actually understand how those algorithms work, and B, good point, who knows what's actually, how much truth there is behind these things that they pretend to know. Mm. Yeah, thank you.
Aaron?
Thanks very much for the talk, Judy. I had a comment and a question. I was thinking about I often try to get students, and even in this vertically integrated projects that we have here, we put in dedicated assessments around getting the students to do reflection. And I was thinking that a lot of what you were showing there could be, the tools given to them to say, look, you have to dig in, you have to basically go through all of these different pieces of the tooling that's actually available to look at your learning journey. And then you have to come up with 3 observations. And it would encourage them to see, A, it would be fulfilling the reflection criteria, but B, they would actually obviously get a big benefit from it. That's more of a comment. The question I had was, when people go to the trouble, because I think your definition of scrutability at the beginning was good to remind us of, that it's work. Like, it's not just something that's kind of like casual in passing. You have to be a very active participant in the scrutability task. You have to kind of dig in, want to find things. But I often find, like just your analogy about Zoom, for example, I discover something and I have very, very difficult for me to somehow communicate that to everybody else, that I've discovered something useful. And how do the interfaces support that? That, like, I've gone to the trouble of discovering something, and then I'd like everyone else I know who's also using the system to also gain from the insights, and then I'd like to gain from their insights. How do systems do that?
I think at the moment they don't do it at all. No one, and I won't say who the person was that. So I gave a talk at AI. No, it was a talk where there was a chance interaction with person. No, someone gave a talk, and we had an interesting interaction. And I believe there are a lot of people there's a big thing in HCI that if we design the interface right, the user will be able to work it out, right? But that's just ridiculous for complex interfaces. And so I think that we just haven't put enough effort into trying to tackle that problem you've described, because the system, something like Zoom, for example, you discover something. I've never seen a list of all the facilities of Zoom where someone's organised them in a way that would make it, sort of a hierarchy that would be easy to work out, ones that are related to each other. And Zoom could surely, I'm logged in, right? It knows who I am. It could easily work out whether I've used them or not. And so that's one part. But if you found something useful, so there was some work done a long time ago. Microsoft was very much, Eric Horvitz was very much committed to this sort of perspective and very influential in having them build their system. So they kept data about people in a way that could do things. Now, Clippy got a bad reputation. I assume everyone's heard of Clippy. But the whole, but it was pretty inscrutable too. Maybe it would have done better if it hadn't been. But the whole idea of collecting data, I think it was great that Microsoft had that idea of at least collecting the data. At the moment, software developers aren't even thinking in terms of, hey, what would this user like to know about what they know, and then share. But there were people in the AI Ed community who took, or maybe user modeling, who took the stuff Microsoft had on use of Word and actually provided stuff, people in certain administrators telling them other administrators often use these tools. And at the time, I'll dig it out again. At the time, the people weren't very interested. But I think the problem is that the time you're willing to learn is pretty special. Most of us are so pressured and so busy. I'm preparing my lecture in a rush. The last thing I can do at that point is be told, hey, here's a new feature you could spend 10 minutes learning about. So it's really tricky, which is why I think an open learner model that I could go to when I'm ready could be very good. And we did some experiments with students who were under time pressure, not because we put them under time pressure, but they had a deadline. And for some mystical reason, they started the homework right near the deadline. But we looked at when they scrutinised and looked at their user model, and when we gave them a quiz. So your point about reflection links with this. So there are points, obviously, for formal education when you've just done a quiz seems to be a sweet point, because firstly, you're ready to stop and think about what you know. It makes sense, right? I don't see us harnessing that at all. Now, as for sharing with other people, I agree. I think that could be very cool. I could imagine you could mark up an interface. I could say, show me the stuff Erin knows, if you're willing to share your data with me.
Even just that ability to say, like, which parts of the interface is Erin actually, touched? I would be happy to kind of share that, because it's the kind of thing, like, it's just, most of the settings are exactly the default, but there's maybe a dozen that aren't. And then you're like, well, why has he changed those? Usually I only discover it because I can see something that somebody has done through the visual interface, and I realize, hang on a second, they've changed something in their settings, which means what I can actually see is different. But there's lots of stuff I can't see.
Yeah, I mean, to be fair to the developers, everyone's under pressure. Just getting it to work must be hard. But I don't know. I just can't understand why we don't have a stronger learning perspective. The old definition of HCI, one of the 5 elements of it was learnability. And learnability, as I just said, isn't just that you've designed it so that any idiot can only get it right. It's also so that all of us can actually make progress and learn more.
Thank you.
Any other questions? Team?
Okay, how do I put on my hand? Okay, got it. All right. Yeah, so basically one comment talking about room, right? So one comment and one question, I guess. So one comment is my personal experience. So I wear the Apple Watch, right? But I just feel very comfortable when I doing my exercise in gym, because it's just uncomfortable, it's wet, right? So I always take off my Apple Watch before I enter the gym. And then when I go out, I put it back on. So I always lost my exercise, which really bothered me. How can I put it back? So that's just a comment. So another thing is I'm curious about the level of scrutability. So my example is in Adelaide. So we have My Uni, right? So the Canvas system where we can upload video. And we also have a separate system called Echo 360, where you can also upload video. And that particular system gives you a lot of information about how many students click that video, what's the viewing percentage. So that's, in a sense, giving more data to scrutinize student activities. But at some point, I just feel, okay, that might be almost too much, right? And I don't know how to make sense of those data. Then I switch back to the more easier to understand My Uni Canvas version of video upload. I'm just curious of what would be the right level of scrutability there.
Okay, that's a great question, because Bob and I are right now struggling because we're working on, actually Bob's trying to use Echo 360 itself, and it's not been designed for building individual learner models.
No.
Getting the individual data out, you've got to go to each one separately, right, Bob? I mean, it's really tedious, and Bob has a lot of tiny little videos each week for the students to watch, so that's really tedious. And if you wanted to update it regularly, and we don't seem to have an API, so firstly, no one's designed that data so that it's easy to build an individual learner model. My guess is, it really is hard. And frankly, the Canvas quizzes and stuff are really hard to build an individual learner model too, because I'm doing that at the moment as well. But we do have a tool called SRES that does some of it and is heading towards more of it. And I think, so it's a piece of middleware that this Danny Liu's passion. He's done amazing work. He wants to personalize teaching, and it's free. You can access it if someone wants to install it at your uni. A number of unis have it. So it grabs the data in a way that at least makes it a little easier to get most of it. Not the Echo 360, he can't get that though. But your question was really, is it worth doing? What level of detail matters? And that's a really good question, but I think it depends on what's an open learner model? It's something that enables you to answer questions. And so the open learner model Bob is designing for his course is, what is my level of engagement? So he has videos that they're meant to watch each week, little ones, and little self-test quizzes that are worth no marks.
Mm-hmm.
And all of that's meant to enable you to do things anytime you like for things that are worth marks. So engagement is doing all of those things. And what we want is to build an open learner model that lets students see where the holes are. How well am I engaged on the various topics? And for that, you really would like to know if we have data that they've played the video. Now, so how useful that will be, well, we'll be finding out a bit more. But I guess there is no single answer. It depends what you'd like to show. So if you wanted to show student engagement, it'd be really nice if you could easily get all the data about all the things we think that indicate that. But bear in mind, two students could, if you're not in lockdown, two students could decide to study together and sit at the one screen. So you don't have them both logged in. It's wonderful that they're watching together and talking about it. Two students may do a quiz together. That may be very valuable too, one way or another. So the data is pretty noisy and you've got to take that into account. But no one's building these systems so that we can make it easy for teachers. But I think we're going to see that change.
Yeah, I just talking about students watching lecture together. So because there's one time in the class, I showed them, hey, this is what Echo 360 tell me. So they were surprised that I can actually show how many times they click on the video. Then so two things happen. Right? So one of them is saying that, yeah, so sometimes we watch video together, so that doesn't really count. And another thing happens next week, somehow the video click increase. Maybe they feel the pressure to click the video. Not sure did they really watch over it though.
Yeah. Of course, you don't know if they watched the video just because it played. No.
Mm-hmm.
And I had a student, Andrew Lum, who did some very cool work on a course we put online a long time ago. And we only had audio. We had PowerPoint slides and audio. And we measured how long the audio track played, whether it played most of it. And we used that to build models and to give them to the students. And they did go back and use that to play things they'd missed, that our system said they'd missed. They only did that when they were revising for the exam. No big surprise.
Okay, I don't see any raising hands. So if there's no more questions, I would like to thank you, Judy, again for this great talk. And thank you everyone for joining this session. So hopefully to see you in our next event, either face-to-face or online again. Thank you very much, Judy.
My pleasure.
Thank you, everyone.